This is 1.7 linear inequalities. So we're going to solve and graph each of these linear inequalities. So some of these you should be familiar with how to solve. So we're going to minus 3x from both sides, and then add 7. So we're going to get 2x is greater than 16, which means x is greater than 8. Now, on a number line, greater than 8 would look like this to the right, and interval notation would be parenthesis at 8 going all the way to infinity. Just as a reminder, if this was an equal sign, then this would be filled in, and then this would be a bracket. Okay, so solve, graph, and then write in interval notation. So let's look at another one. So to solve this, there's a couple ways we could do this problem, but a lot of times what I recommend is a lot of us don't prefer fractions. So what we could do is look at the fractions, the denominators, and find the common denominator, which there's only one fraction here. It's 2 is the denominator. So if we multiply everything by 2, like literally multiply that by 2, multiply this by 2, multiply this by 2, multiply this by 2, and so this gets 2. Here the 2's crossed out. So notice I get 3x. Notice the fraction is gone. And that's what I want to do. I want to solve for x. So bring the 3x over, so that's 5x. The 8 over there, that's 10. Divide by 5. And normally, by the way, I strongly recommend that you write your x on the left-hand side. So that's actually x is less than or equal to 2. Again, this and this are the same exact thing. So I strongly encourage you to write your x on the left side. That way, when you graph for 2, x is less than or equal to, so you have a filled-in circle, and it's going to the left. Sometimes people memorize it, the arrows will match. Well, the arrows will match only if x is on the left side, okay? Only if x is on the left side, then the arrows will match. And then this would be a negative infinity all the way to 2 with a bracket. That would be the interval notation for that. All right, let's look at, these are called like compound inequalities or double inequalities. So I have, it looks like the same problem, but notice one of them is a positive 6x and the other one is a negative 6x. So I'm going to do both of these. So we're basically going to add 1 to all 3 sides, or all 3 areas. You have a middle section, a right section, and then a left section. And then divide everything by 6. So you're going to get 2/3 and negative 1/3. So x is in between those. Now, if we graph those, notice you have negative 1/3 and you have 2/3, and they're both filled in, or in interval notation, it would look like that. So x is anywhere in between those fractions, and if you want to put 0, 0 is right there on the number line. Now, if you solve this the exact same way, so we're going to add 1 to both sides. You're still going to get 4, negative 2. Now, when we divide by a negative 6, remember when you divide by a negative, it's going to change the inequalities as well. Because I'm dividing by a negative. So we're going to get this answer. Now, I want you to notice what this answer actually says. Because a lot of students might get this part. They might solve it, but they might actually look at this and say, what in the world is this? So notice this is saying x is greater or equal to negative 2/3. Greater or equal to negative 2/3. That's what that says. And this part right here says x is less than or equal to 1/3. So on a number line, you have 1/3, you have negative 2/3, and notice it says x is greater or equal to negative 2/3, you have less than or equal to 1/3. So you have to pay attention to this, because sometimes when you look at this graph, sometimes the graph, it actually may be going different directions. Okay, so you have to pay attention. So literally what it says, you have to pay attention, look at each part of it, and then graph that. And of course the interval notation would be both brackets on this as well. So I just wanted to go over, especially dividing by negative, how to solve that. Now, absolute values. Now, let me remind you how to do absolute value equations. So if I had an absolute value equation, just like equals to. So the inside value, just to remind you, the absolute value of 2 is 2. The absolute value of negative 2 is 2. The only way to get 2 is if the inside value is 2 or if the inside value is negative 2. That is the only way to get that. So that means if I have this problem up here, that means x minus 5 has to be 2 or has to be negative 2 because that's the inside value and the result is 2, so that means the inside value could be 2 or the inside value could be negative 2. And then you solve those and you're going to get 7, and solve this, you're going to get 3. And so you're going to, both of those answers actually work. Like if you plug those in, you plug 7 in, 7 minus 5 is 2, the absolute value of 2 is 2, it works. Plug in 3, 3 minus 5 is negative 2, the absolute value of negative 2 is 2, it works. Both of those answers always works. So when you solve absolute value equations, you're going to get two different answers. So here, with the same idea, you're going to literally take the inside value and set it up as two separate problems. Is less than 2, x minus 5. Now, when you do negative 2, you also switch the inequality. And you're like, well, why do you switch it? Well, it's really, what you're really doing is doing the negative of that. So when you divide by negative, it really changes the inequality. So just remember when you do that, it changes, when you do the negative, it changes the inequality as well. So this is going to be x is less than 7, and this is going to be x is greater than 3. And then when you graph this, just pay attention, this is 3, this is 7, and less than 7, greater than 3, so it's going to look like this. By the way, they're not always connected. I want to be clear on that, they're not always connected. So, and by the way, this is one way to do the problem, but let me show you another possible way. See how I split that into two problems? You can do it that way if you want. Another quicker way to do it is just take that inside value and write what you see, and then just copy it over like that. And see, if you do it this way, you can add 5. Same answers I did up there. So I think it's better if we just do it this way because it's so much easier. So if we look at one more example. So and I'm going to show you the quicker way, the way I just now did it. So if we did negative 2x plus 1, it's less than or equal to 3. But now I'm going to copy it over here and put negative 3. So if I solve this, I'm going to subtract 1 from both sides. Then I'm going to divide by a negative 2. So it's going to change the inequalities and dividing by negative 2. And I'm going to get that expression. So notice what this says. That's x is greater or equal to negative 1. So that's that right there. And this right here says x is less than or equal to 2. So here's 2 less than or equal to. So, and then I graph those two problems. And again, every one of my illustrations went toward each other. Sometimes the graphs will go opposite directions, okay? So just make sure you read the symbols and graph them accordingly. So that's how you solve absolute values and inequalities. Solve, graph, and write in interval notation.